Welcome back to digital class, and this is a discussion for booklet number 6, circles, and now we are looking at page 15, question number 5. Now, this question actually can consider as one of the challenging questions in paper 2 under circle. Okay, so it's very important for you to focus and to know how to solve this kind of question. Now, let's look at this question. Here say that the figure below is made of two semicircles, right angle triangle. So as you can see, this is one semicircle, another semicircle, and there's another triangle here. Okay? And the questions continue to say that the diameter of two semicircles AB and BC are 12 cm and 16 cm. The two semicircles meet at X, which is this part. AC is 20 cm. Find the area of the shaded area. Now, the question here comes that, now teacher, if you ask me something like this, I can solve the shaded area. If you ask me something like this, I can solve. But now, this is not even a shape. How can I find the area? Now, and this is the time that we need to solve using some tricks here. Okay? So now what I would always suggest you to try to do if you can't figure out straight away is that you name 1, 2, 3 or ABC on each of the region. For example, we can see that this is the first region, small one, 1, I name it as 1, I name it as 2, I name it as 3, I name it as 4, I name it as 5. Can you see that each part of the region I name it as 1, 2, 3, 4, 5. And now, I know that it's always easier for me to calculate a semicircle or a triangle. So let me just write down here. You see, this is a semicircle that have what? 1, 2, and 3. So I like here 1, 2, and 3. And I can see that this is what? This is actually a triangle. I know that there's another triangle here, and it covers 2, 3, 4. 2, 3, 4. And there's another big semicircle here, which I know is actually what? It's actually 3, 4, 5. Now, the reason I put a number there is actually it helps me a lot when I do the calculation. And basically means that if I calculate the area of this semicircle, it will give me the area for 1, 2, and 3. If I calculate the area of this triangle, it will give me 2, 3, and 4. If I calculate the semicircle, it will give me 3, 4, and 5. So far so good? Should be fine, right? Now, let's try to look at here. Our target, now the question is asking us to find the area of the shaded area. Means that the target area that we are looking at is actually 1, can you see that? 1, 3, and 5. 1, 3, and 5. Which means that now I need to somehow plus or minus to get only 1, 3, and 5. Now, let's look at here. Let me use a highlighter to highlight. Now, my target is to look for 1, 3, and 5. Now, out of these 3 shapes, which one has 1? We know that only the first one has 1. Is that correct? Now, the second one, which one has 3? Oh, I can see that this one has 3, this one has 3, this one also has 3. So let's just ignore that first. Which one has 5? Okay, we know that this one has 5. Means that for sure I need to add these two together so that I have all of the 1, 3, 5. And can you see that if I add this, okay, let me just quickly just do it here. If I use this semicircle plus with this semicircle, basically now I have 1, 2, 3, and 3, 4, 5. Can you see that? I have 1, 2, 3, and 3, 4, 5. But let's say 1, 2, 3, 3, 4, 5. But did you notice that if I have 1, 3, and 5 already, but again, my target is to only look for what? It's only look for 1, 3, and 5. I don't want this leftover 2, which is this 2. I don't want leftover this 3 and this 4. This 3 and this 4. So what should I do actually to remove away the 2, 3, and 4? Because I only 1, 3, and 5. So it's very obvious that we actually can look for 1, 3, 5 only. by minus away the triangle, because triangle is 2, 3, and 4. Okay, let me just quickly highlight for you. I want to minus away this 2, 3, and 4, and obviously 2, 3, and 4 is given here, so I can just straight away add these two semicircle and minus away this triangle. Then I can straight away look for the area of the shaded area. Okay, so I hope this concept or these ways actually helps you to find out the answer. Okay, you'll be seeing this kind of question later on in the next few pages or so. So let's try this. To find for the area of this, find out area for this, I know is, again, I was given this 12 cm as my diameter, so my radius is actually 6 cm. So again, pi r squared, and this is semicircle, so it's half pi r squared. So half times pi, we are given 3.14, times r, which is 6 squared. So if you press on the calculator, it's 56.52 cm squared. Again, let's try to look for the semicircle in this one. Again, it's a semicircle, so it's half pi r squared. So it's half times pi, which is 3.14. And what is my radius now? Again, my diameter is 16 cm. So my radius here is 8 cm. So it's 8 square. So 1 over 2 times 3.14 times 8 square, if you press on your calculator, is 100.48 cm squared. And of course, the last one we need to find is this triangles. So triangle is very simple, right? I know the height is 12. I know the base is 16. And again, this is a triangle, so it's half times base times height, half times 12 times 16. So I simplify, and it's equal to 96 cm squared. And again, it's very simple. We just need to follow what we have found here, is that the semicircle plus the semicircle minus the triangle. So it's 56.52 plus 100.48 minus 96. And you press on the calculator and you will find the answer is supposed to be, let's press on my calculator. Yeah, I know already, 61 cm squared. And we are done for this question. So something simple, is it something simple? Just that we need to figure out the numbers that we have here. Okay, so again, you can try it out first, try to figure out and think about it. And if you still don't understand, you can continue to watch the video for the next one. And of course, you can ask me in the class. Thank you so much, and I hope this helps you. See you. Thank you. Bye bye.